Okay class, today we're in section 6.3, solve linear systems by adding or subtracting. Before, you solved linear systems by graphing and using substitution. Now, you will solve linear systems using elimination. Why? So you can solve a problem about arranging flowers, as in exercise 42. Key vocabulary: systems of linear equations. When solving a linear system, you can sometimes add or subtract the equations to obtain a new equation in one variable. This method is called elimination. Key concept: solving a linear system using the elimination method. Step 1. Add or subtract the equations to eliminate one variable. Step 2. Solve the resulting equation for the other variable. Step 3. Substitute in either original equation to find the value of the eliminated variable. Example 1. Use addition to eliminate a variable. Solve the linear system 2x plus 3y is equal to 11. Negative 2x plus 5y is equal to 13. Solution. Step 1. Add the equations to eliminate one variable. Notice how the problem is aligned here, and notice how it is aligned here. Notice how they have the x's right up under each other, the y's right up under each other, and the constants right up under each other. Now here you can eliminate. One's positive, one is negative, so you add going down. A negative 2x minus 2x is 0, and you're left with 3y plus 5y, that's 8y. 11 plus 13 is 24. So now you have 8y is equal to 24. Solve for y. You're going to divide both sides by 8, here and here. 8 divided by 8 will leave you with 1, so you have 1y. 24 divided by 8 is equal to 3. So y is equal to 3. Step 3. Substitute 3 for y in either equation and solve for x. 2x plus 3y is equal to 11. That was equation 1 of the two equations. They could have picked either equation to work with. You always try to pick the easiest one. Notice this one, the top one, does not have a negative number. So 2x plus 3 times 3 is equal to 11. 2x plus 3 times 3 is equal to 11. We solve for x and we end up with 1. A basic review: 2x plus 3 times 3 is equal to 11. 2x plus 9, 3 times 3 is 9, is equal to 11. I'm trying to get my x by itself. So the first thing I want to get rid of is this positive 9. So I subtract 9 from each side. The 9's will cancel, and I'm left with 2x is equal to 11 minus 9, which is 2, and x is equal to 1. So in this case, x is equal to 1, y is equal to 3. My solution is 1, 3. Example 2. Use subtraction to eliminate a variable. Solve the linear system 4x plus 3y is equal to 2, and 5x plus 3y is equal to a negative 2. Solution. Step 1. Subtract the equations to eliminate one variable. Notice our equations: 4x plus 3y is equal to 2. 5x plus 3y is equal to negative 2. You see I have 2 3y's there. If I were to add going down, I would come out with 6y, and nothing would be eliminated. So therefore I must subtract. And when I subtract, that means that I'm going to be using a negative sign, or the distributive property, all the way through. So everything in here becomes its opposite. So 5x becomes a negative 5x. 3y becomes a negative 3y. A negative 2 becomes a positive 2. Notice when I do that, now my y's can be eliminated. They're going to disappear. So here I got 4x minus 5x. That's going to be a negative x. A positive 3y, when combined with a negative 3y, that's now going to 0. That's why that's gone. And then 2 minus a negative 2 will end up being 4. Or in other words, 2 plus 2 is 4. So x is equal to a negative 4. Once again on this side, here I would get a negative x is equal to 4. I got to get rid of that negative x. There's a 1 in front of it, so I'm going to put the 1 right there. That means I must divide through by a negative 1. And when I do that, x is equal to a negative 4. Okay, now for step 3, we're going to substitute. We found that x was equal to a negative 4. So in one of the two equations, we're going to put in negative 4. Here we choose the equation 4x plus 3y is equal to 2. In place of x, we're going to put that negative 4. So now I got 4 times a negative 4 plus 3y is equal to 2. All right, now what's 4 times 4? What is 4 times a negative 4? That's going to be equal to a negative 16 plus 3y, and that's equal to 2. So I'm solving for y, so I got plus 16 plus 16. All right, it's because I want to get the 3y by itself. That's going to disappear. So now I have 3y is equal to 18. Divide both sides by 3, divide both sides by 3, and y is equal to 6. So my answer is negative 4, 6. Example 3, arrange like terms. Solve the linear system 8x minus 4y is equal to a negative 4, and 4y is equal to 3x plus 14. Solution. Step 1. Rewrite equation 2 so that the like terms are arranged in columns. So in other words, what I want to do is I want to take equation 2 and write it in the same form as equation 1. That is, my x term is first, my y term is second, and my constant is sitting by itself. So in this equation, that means that the 3x should be moved to this side. The 3x should be moved. So to do that, I'll take the equation. I'll say minus 3x on one side and minus 3x on the other side. All right, now write what I have. I'm going to end up with a negative 3x plus 4y, and that is equal to 14. So now x is first, y is next, and the constant is next. Okay, now that I've rearranged and everything's in the proper column, so I went from this to this, now I can add going down because I can see that my y's will be eliminated. One's negative, one's positive. So 8x minus 3x is 5x. A negative 4y plus 4y, that's gone. And a negative 4 plus 14 is equal to 10. Divide both sides by 5 and x is equal to 2. Okay, now that I have solved for x, I'm going to take that x value and plug it into one of my equations. So I'm going to use the top equation, 4y is equal to 3x plus 14. In place of x, I'm going to put that 2 that we found. So 4y is equal to 4y is equal to 3 times 2 plus 14. All right, and then once again, doing our math, 4y equals 3 times 2 plus 14. So 4y equals 6 plus 14. So 4y equals 20. And then divide both sides by 4, and y is equal to 5. So my solution then is going to be 2, 5. Example 4. Write and solve a linear system. Kayaking. During a kayaking trip, a kayaker travels 12 miles upstream, that's against the current, and then 12 miles downstream, that's with the current, as shown. Upstream, That's against the current. The current is going this way. That's the black arrow. Downstream, he's going in the same direction as the current, so that's going to be added to. This will be subtracted from. The speed of the current remained constant during the trip. Find the average speed of the kayak in still water and the speed of the current. Step 1. Write a system of equations. First, find the speed of the kayak going upstream and the speed of the kayak going downstream. Upstream, distance is equal to rate times time. The distance was 12, the rate we don't know, and the time was 3 hours. So we solve this for r. So we end up dividing both sides by 3, and r is equal to 4. Downstream, distance is equal to rate times time also. Distance is 12, the rate we don't know, and the time is 2, as in 2 hours. Here we divide both sides by 2, and r is equal to 6. Use the speeds to write a linear system. Let x be the average speed of the kayak in still water, and let y be the speed of the current. Equation 1, going upstream. The speed of the kayak in still water, x. The speed of the current, y. The speed of a kayak going upstream, we determine that to be 4. So x minus y is equal to 4. Equation 2, going downstream. The speed of the kayak in still water is x. The speed of the current is a positive y. And the speed of the kayak going downstream, we determine that to be 6. Step 2. Solve the system of equations. The first equation, x minus y is equal to 4. The second equation, x plus y is equal to 6. We see that our y's can be eliminated just by adding going down. X plus x is 2x. A negative y when combined with a positive y goes to 0. 4 plus 6 is 10. So 2x is equal to 10. Divide both sides by 2, and x is equal to 5. Substitute 5 for x in equation 2 and solve for y. 5 plus y is equal to 6. So once again, in place of x, we put that 5. So 5 plus y is equal to 6. We solve this for y. Minus 5 minus 5. 5 minus 5 is 0. 6 minus 5 is 1. And y is equal to 1. So the average speed of the kayak in still water is 5 miles per hour. And the speed of the current is 1 mile per hour. You may now start your assignment.